Hello, and welcome to CFE Media's Virtual Training Week. For this session on outstanding applications in maintenance and quality 4.0, we'll be joined by Mo Abuali, Managing Partner, IoTco, Isaac Bennett, Director of IT and Digital Transformation, Wright and McGill Company, and Tyrone Ellis, Enterprise Director, Global Engineering Excellence, Train Technologies. I'm Kevin Parker, an editor with CFE Media and Technology. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. Reducing unplanned downtime or minimizing scrap by even a few percentage points can yield millions of dollars in savings for manufacturers. Leading manufacturers leverage the industrial Internet of Things, machine learning, and metrics to achieve shop floor efficiency and productivity. The question is, does your organization have the necessary organizational and technical maturity to embark on Industry 4.0 and predictive analytics projects? You'll be better able to answer that question once you've attended this presentation on real-world applications of IIoT and Industry 4.0 to implement predictive analytics for core manufacturing processes. The presenters will also discuss the digital tools of the trade that support Industry 4.0 with a systematic approach, with a focus on connectivity and data management, as well as the return on investment that can be wrung from maintenance and quality 4.0 projects. Learning objectives for today's program include knowing why it's time to act now, knowing when it's time to act now, how to demonstrate leadership, and how to build a business case for Industry 4.0 and predictive analytics, and how to get started. How to think big, start small, and deliver. How to take a systematic approach to drive the right technology adoption and scale as needed. And finally, learn how to empower maintenance and quality personnel with predictive and prescriptive insights. Here are some tips to help you get the most from today's session. Additional resources can be viewed and downloaded on the left-hand side of the screen below the session's agenda. If you would like to take notes within the session, click on the left panel labeled Notes to do so. If you cannot attend the whole session today, you can view it in your dashboard on demand. You can also see the Q&A details in the Meeting tab on the left-hand side of the screen, or Zoom invite details can be found in the Additional Resources tab under Q&A session. You will be able to immediately join the Q&A after you view the session. Click on Join Meetings to enter. If you're experiencing technical difficulties, please log out and then back into the session to continue. The exam will be posted on CFE Media websites with the on-demand version of this webcast. The exam is for one RECEP ASIC Certified Professional Development Hour. I would now like to introduce you to our speakers, starting with Mo Abuali. Mo, please tell us a little bit about yourself and then go ahead.
Thank you so much, Kevin. I'm very pleased also to be here with Tyrone Ellis from Train Technologies and Isaac Bennett from Wright and McGill. I'd like to give a short presentation to set the stage and then have Tyrone present and introduce himself, and Isaac will also present and introduce himself. Then we'll open up the conversation for Q&A time. So my name is Mo, and I've been in the industry for about 22 years. Been doing analytics on maintenance 4.0 and quality 4.0 applications in the automotive industry, and recently with IoT company, providing software services and technologies to a variety of industries. I read technology and delivery at IoT company, and we as an organization, our DNA is really the manufacturing space. We come from manufacturing and we serve manufacturing with the technologies they need and the services they need to realize their smart factory journeys. And we all know that takes time. We all know that it's a journey, it's a maturity curve. And therefore, at IoT Company, we provide a set of technologies that provide an end-to-end approach and a systematic approach from the advisory and training to the analytics and to the needed IoT efforts to make things happen. So the field of IoT is by no means not a new field, actually. So safety critical industries, including jet aviation, power gen, and other spaces, have adopted IoT technologies for many years, primarily to reduce safety and risks in their industries. In the field of IIoT, which is in the industrial or manufacturing space, if you look at within the plant operation, there is usually multiple layers on this automation pyramid here, from the sensor machine layer to the data acquisition layer to the execution layer to the business layer, which is your ERP systems. But in many cases, those I would say layers are siloed, and some of them may not exist. In many situations, the IT, the information technology layer, and the operational technology layer have not converged. So the reason for realizing and implementing Industry 4.0 technologies is to bring that convergence and the technology, people, process behind it that could support the movement from Industry 3.0 to Industry 4.0 solutions. And therefore, when you think about your digital journey and analytics strategy, we typically like to think about four things, which are going to be kind of the pillars of the conversation today. Starting with the return on investment, actually, and kind of going backwards. What is the business case and the use case for implementing these technologies today? And then what type of connectivity and readiness on the plant floor to implement those solutions, keeping in mind new machines, old machines, new systems, old systems. And what are the analytics that are best fit for the operation? Different operations have different maturity levels. And then the technology itself, the infrastructure needed to implement and scale these technologies across the plant floor. So if we go first into the business case, there are many metrics out there that are used today by manufacturers, but it is important to collect data in real time in order to allow for real-time metrics in the operation. One of those key metrics is OEE, for example, overall equipment effectiveness. That's your uptime, performance, and quality. And by adopting Maintenance 4.0 and Quality 4.0 solutions, we're able to start detecting and mitigating downtime issues before they happen. We're able to start tying into spare parts systems to improve the way spare parts are allocated, but not only that, but the way maintenance is scheduled and the way labor is scheduled. We've seen organizations that have improved their mean time to repairs and mean time between failures to the level where they actually eliminated firefighting maintenance activities on the weekends, for example. And then with predictive quality, it's about detecting and predicting scrap and quality issues before they even happen on the factory floor by using AI to start correlating process data, machine data, and quality data, right? But as we talk about digital maturity, we also talk about AI maturity on the factory floor. And as we mature our technology, process, and people, we're able to start driving our operation towards a zero downtime and a true zero defect manufacturing plant. So with this in mind, predictive analytics is really about worry-free productivity. I want to run my operations without worries of machines going down or making bad parts. And therefore, if you look at a high-level architecture of a kind of a PDX 4.0 type of solution, we're talking about meaningful data and metrics that is captured. We're talking about ingesting and converting that data into meaningful metrics so that the maintenance and quality functions can use it in a proactive fashion, not a reactive fashion, to understand machine health, diagnostics, and predictions before they fail, and to even look at their parts while being produced and to understand and detect if I'm making a bad part or a bad batch before I produce it and before it goes to the next value stream in my process. So keeping in mind the breadth and depth of manufacturing processes out there today, we collaborate and create templates for maintenance 4.0 and quality 4.0 applications. And some of those templates include robotics, where you have joints and axes that fail. CNC machine tools, where you have bearings and tools that fail. Casting, welding, machining, molding. And in the example, actually, that Tyrone will show later, press operations, press machines, where you got a lot of moving parts, and vibration detection is important to mitigate press failures before they happen. And last but not least, surrounding ancillary equipment like pumps, motors, and gearboxes, and so on. So it's important to understand how these templates work and kind of the role of industrial AI. It starts with an understanding of the critical components. So we're talking complex processes, complex lines, complex cells, but there are critical components that fail. And some of those critical components include bearings and feed axes and tools. So it's important to acquire the right data from those critical components, to have a data model that is scalable, that enables us to capture data from the PLC and potentially add on sensors like vibration, and digest that data, implement AI on that data in a short period of time. But at the back end of it, we do not expect the user to be a PhD or a data scientist. The user is a maintenance manager, a quality manager who wants to run his operation in a better way. So by showing him or her an intuitive, trusted user interface where they can see machine health, they can see predictions, and they can see diagnostics is very key, so that they could run their business in a better way and become more efficient and kind of go towards their journey of zero downtime and zero defect manufacturing. So to paint the picture, we're very grateful for the time that Tyrone and Isaac are giving us today, and they're going to both share their kind of success stories relating to maintenance 4.0 and quality 4.0. So starting with Tyrone. Tyrone, welcome.
Great, thanks Mo for the intro. I'm Tyrone Ellis, the aftermarket engineering leader for Train Technologies. I actually just recently transitioned into that role, and when we started this project and worked on IoTco, I was actually Global Engineering Excellence Director for the company at our corporate office. I've been in operations for 20 plus years in a lot of different roles, primarily with automotive for the majority of that time, and been with Train Technologies, the current organization, for the past since 2012, so approaching 9 years. So Train Technologies, who are we? Train is a global climate innovator that actually has been around for 1 year. We were a spinoff of from Ingersoll Rand with our climate businesses, which we primarily go to market and across the globe with brands that kind of serve a specific portion of sustainability, climate, when it comes to buildings, homes, and transportation. Most people know Train, the HVAC brand for commercial and residential, as well as Thermo King when it comes to thermal transport, which is another well-known brand that's under our suite of brands. And so Train is really focused, kind of reinvented itself as a sustainability company, really focused on global climate. And we're excited to really have the purpose that we have as an organization, which is this project was a great lead in into just how we're approaching and thinking about being sustainable. Next slide. And so the facility that we are working with IoTco on Predictive Analytics is in Columbia, South Carolina, our Train plant there, which is a part of our commercial HVAC business unit. We've been, I guess that plant has been a part of our footprint since 2003. And at that time was probably more of a feeder plant to our other facilities that we have for that specific business unit. But we made a decision based on that plant's performance over time and to actually expand it in 2017. And so the campus there has more than 80 plus acres, and we actually expanded it to over 1 million square feet, and now it currently has more than 1,000 people. And so we were able to add 750 plus jobs to the community and really bring in some other sites that were in other parts of the country to really expand what this plant was doing as a part of our business unit strategy. Now, what's interesting, the challenge that brought forth was a plethora of equipment of various ages. And so when you think about older equipment with newer equipment, and some with certain capabilities and some not, it created a pretty complex footprint of what this plant looked like with the integration of 3 facilities into one. And so we'll talk about that as a specific in the project, but that was really one of the challenges that this plant has when it comes to predictive maintenance and some of the things that we're really focused on as an organization. So this plant is a LEED certified facility, and we're excited about that, and it fits our sustainability commitment for carbon neutral operations by 2030. And the site is very involved in the community as we are across the globe with most of our facilities. So the project specifically, as I mentioned, I gave you a little bit of the landscape and what's happening at the plant. And so we actually implemented the PDX solution from IoTco, really focused on the uptime component of OEE to reduce, obviously, to improve OEE, but to really focus on press machines, as Mo mentioned earlier in the presentation. We were really intentional with that choice. The reason why that was an important decision for us, because this is actually a piece of equipment or type of equipment that we have all over our company in this business unit and other business units actually as well. And so in order to ensure that we could show the value for the project as well as the value of the PDX solution integrated into that, we wanted to be really, really intentional about our focus and choice for the equipment. And so as Mo kind of gave some insight earlier about the importance of choosing the right critical components, this was a great example of how we needed to do that for this specific project. And the approach that we've used is a plan for every machine. And so when you have that kind of complexity at a site where old and new equipment, different level of capabilities and so forth, you have to examine each machine specifically for its current state. And so we decided that for the critical components for this particular machine, it was bearings and pumps and motors. And so the data model that we needed to create based on that, I think that the chart to the right is really important because it's a great way to show normal versus abnormal as we, for our operators, our technicians, and our equipment improvement teams is the approach that we use at our sites. We had to evaluate, what sensors did we need? And so add-on sensors in this case for vibration, what can we get from the controller, and so forth. And so the project really led to that kind of thinking where we've got a cross-functional team really focused on that plan for every machine and what, beginning with the end in mind, that's going to lead to the output that you see on the right that really tells us, again, that normal versus abnormal opportunity, easy to understand for our teams to go and execute so we can become predictive and stop a downtime event before it becomes an event and do planned maintenance based on the models we created. So with that, just to summarize the project on the next slide, some key takeaways for us were think big, start small, and scale fast. This concept was has been the theme of this project from the start. As I mentioned, we were very intentional with the selection of the equipment, and so but our whole thought process was we're going to scale this across globally across our organization. And so by starting small and really proving out the model and showing the return on the investment is where we needed to start. And so we are expecting in less than a year, approximately 50% improvement in asset uptime. And certainly believe there's opportunities to make that even better. One thing that was really important in this was the empowerment and the excitement this project has generated. So we've got our manufacturing engineers, our advanced manufacturing team, our IT organization, our even our procurement and all the key stakeholders that are involved in this project. We intentionally did that from the start as well. And so by involving the whole cross-functional team into the project has led to a lot of excitement about what this is going to yield for us as an organization. Next key takeaway was the PDX solution was chosen because we need a short time to value. And in manufacturing, this is what we do. We need projects done faster, high impact and so forth. And so we really were a fan of the templates that Mo showed earlier in the deck that in order to shorten that time to value to get the project implemented. And I can personally say we've seen that through the execution of the project with those templates really helping to save substantial amount of time. In versus if we didn't have them in order to start this project. The other thing I would point out was just the practitioners and subject matter expert advice we've been able to yield from IoTco has been important for us, as well as key things like domain capabilities, project managers, and data scientists have been a big part of this project in order to help us to come up with that vision around start small, scaling fast. And this has been a big part of their whole, expertise in advising us has really helped us to really get to where we are. And the center of excellence approach, last and certainly not least, is really important. And so in order to sustain this and do what we need to do across the globe, we really need that expertise within our own people. And so IoTco has been able to offer that through their academy and the training research resources when it comes to helping us to get up to speed in order to scale this project fast. And so we've had some other stakeholders with us when it comes to some of our in-state organizations that have been a benefit. So with the South Carolina Research Authority and the South Carolina MEP branches or offices, they've been really beneficial to the project and serve our manufacturing base in the state. And so those two organizations certainly were a big part of this project to really help us move forward. And so our recommendation is this is not an option. We think all manufacturers need to get engaged quickly because Industry 4.0 and this type of projects and strategy are here to stay. In fact, getting into it, proving return on investment, and then being intentional about how we scale is what we recommend. So great project, and we're looking forward to the continuance of it as we move forward.
Thank you, Tyrone, for your presentation. We really appreciate your insights about using predictive analytics on your factory floor. Also pleased to announce having Isaac Bennett here with us today. Isaac, I would love if you introduce yourself and share your story.
Yeah, thanks, Mo. I'm glad to be here today, talking with everyone on the call. I am an IT person, so you're going to hear a little bit a different perspective than Mo and Tyrone, but I think a lot of the themes will be the same. But yeah, so I've been in IT for about 20 years. I've been in automotive for I think 11 now. Actually, just recently escaped automotive. So I'm in manufacturing now in the consumer goods sector. A lot of the stuff I'll talk about is going to come from automotive, and I also talk about a little bit about a specific instance with Detroit Manufacturing Systems. Yeah, so I've been in IT for a while, and I've been doing smart manufacturing, I don't know, for about 6-7 years now. So I've been in it a while and learned a lot of good lessons from it. The one thing I can tell you is the technology works. I think we're kind of over the hype cycle. If you're familiar with the kind of hype cycle where, you know, the expectations of Industry 4.0 are super, super high. I think that's kind of leveled out, but it's not going away. I think Tyrone said it. It's going to continue. And I think, you know, the technologies have been around. It's just a matter of someone labeling it and putting the framework around it, around Industry 4.0. Yeah, so you can go to the next slide, Mo. And I wanted to talk about Detroit Manufacturing Systems, where I was working, because it's a little bit different than traditional manufacturing. And I think it gives you another perspective too of Industry 4.0. But Detroit Manufacturing Systems is a great company, great leadership there. It was founded in 2012, trying to bring manufacturing back to the city of Detroit. So it is indeed in the city of Detroit. It's a joint venture with Forcia. We do have plants in Detroit, and then we also have one in Toledo. And it's a tier 1 component manufacturer, and they do some injection molding. So they do have some machines there for injection molding, but their big part of their core business is value add assembly with just in time and just in sequence. So with that process, you can imagine an assembly line. There's a lot of people involved with that. So you put people into the equation of you know, predictive, and people sometimes are very, very hard to predict. But there is some value off of the data that we can get in that type of environment. And so you can see pictures too of the kind of stuff that they assembled. The one on the left is a Ford F-150, and then you can see the Jeep there on the right. You can go to the next slide, Mo. So yeah, so I've been doing this type of thing for a while, and Tyrone landed on some of these concepts, and so did Mo, talking about how machines were at different levels. Plants were at different levels. Departments are not talking to each other. So that was one of the biggest obstacles I find, you know, and we talk about it a lot in IT, of the concept of people and process before technology. And that is never truer than it is with the digital transformation and smart manufacturing and trying to get one of these projects off the ground. And so, and it's not just people and departments, but it's the machines and the factories. There are, you know, different levels of technology, different processes going on. So generally, there's no standard solution for one of the most important things, and that's getting the data and figuring out what to do with the data. So a lot of times the data is not even gathered, or it's gathered just because we have compliance, and that's why we gathered the data. You can go to the next slide, Mo. And I wanted to talk about how Industry 4.0 can be really overwhelming as well. There's a lot of different technologies that can be involved with Industry 4.0. You know, we're talking specifically about doing some predictive analytics and artificial intelligence. That itself can be overwhelming, not knowing what that is. But I'll re-emphasize that really, for me, at the core of it, in trying to do a project like this and trying to get it off the ground and trying to get value from a project like this, the core of it is really that data. Where can you collect data, and what can you do with that data? And so for me, that's the central idea, is data analytics is the core capability. And we're talking about that now, of what exactly we can do with that data analytics. And then the connectivity. Connectivity for me as an IT person is huge. How do we connect that data and get that data to where we need to get it to? And I'll say this, in it kind of alludes to it on the right side if you want to read that quote. I'm not going to read it line for line, but it really is, this day and age with the COVID pandemic has really emphasized and showed you know, what companies can succeed and what companies will fail. And that's the companies that are going to be the learning, agile companies, the companies that can shift fast, because we as IT have had to shift very fast when the pandemic hit and a bunch of people started working at home. it's the same type of concept. I mean, information travels across this world so quickly, so fast, and economies can change so quickly. If you're not a company that can adjust quickly and is agile, I think you're going to fail. And I think this type of technology that we're talking about today is what enables that agility. Yeah, you can go to the next slide. Yeah, so specifically with Detroit Manufacturing Systems, we really saw the value of where to collect the data, despite the fact that we have a lot of people that are doing manual assembly. They're putting torque screws in and doing things like that. But we really wanted to see and have more visibility to the plant floor and what's happening, even down to the operators. If we can have a station where we know exactly what operator lines up to that specific station and what their strength is, I think there's a lot of data that we can get from that as far as predictive, and possibly we can take data from the line, whether the line stopped, whether a torque gun did this, did that. There's a lot of data that we can gather. The issue is that we don't have that data. So at Detroit Manufacturing Systems, we really wanted to put in a strong MES solution, manufacturing execution system. That was a strong system that we could collect the same data across the plant. We talk about the silos, break down those silos, be able to put that data in the same area, and then try to get the value from that data. Because the first step is trying to get the data, and then we need to try to figure out how to get that data to be important. And Tyrone said it, this top says it, you think big, start small. And I know some people don't like to hear it, but fail small. That's important, because I think with any innovation and with anything that you want to improve on, you're going to fail sometimes. And I think we need to allow that. And I wanted to make sure that we put that in there. So, and also in Detroit Manufacturing, they didn't collect data from their injection molding, and their injection molding, it had a lot of quality issues. So we really wanted to match that with the data that we're getting from those machines and try to figure out why we're having quality issues. And to do that, we needed to plug those machines into an MES system, gather that data off those systems, and then start doing some AI, predictive maintenance, predictive quality against those machines. You can go to the next slide. Yeah. So it's all about gathering data for me, making sure that we break down the silos, not just the data silos, but the people silos. I think you heard Tyrone talk about the fact that all the different departments they had to gather in to make this work. And I know the technology works. And I'll give you a really brief story about AI and using machine learning. It's not just talk. We've had a very old machine in Akron, Ohio. It was a 60, 70, I mean, maybe even an 80-year-old machine. You don't have to reinvent the wheel. You don't have to go out and spend a ton of CapEx. We were able to retrofit those machines with some sensors and start gathering data off of them. And that was a machine that if it failed, it brought down an entire line in the plant. And we were able to do that in a very short time. It was 2 to 3 months that we have that machine wired up and sending data to the cloud, and then having the data model trained so that we could see what's happening with that machine. And once we did that, they actually the model predicted the machine would fail in like 10 days. And well, they wanted to see if it was going to fail. It indeed failed on the 10th day, and they were down for, I think, 2 weeks. So the technology does work. It's a matter of finding the low-hanging fruit, a simple, small project that you can prove it, that is scalable, and that you can get some big value from. So that's my message to you today. So thanks, Mo.
Thank you very much, Isaac. And thank you, Tyrone, for your insights.
I got a few questions I'd like to ask each of you. Tyrone, let's start with you. And one of the most interesting parts about these kinds of projects is getting the approval to go ahead and getting the justification afterwards. In other words, we're talking about return on investment. What kind of exercises did you have to go through entering into the project, and what kind of exercises did you have to go through exiting the project in terms of demonstrating or proving return on investment?
Yeah, great question, Kevin. The key to any of these type projects is defining what problem we're trying to solve for the business. And so if you think about the complexity that I described for for the manufacturing plant in Colombia, with that many assets and the just the landscape and complexity around that, it drives the need for this kind of project. And so, especially when it comes to the real bottom line impact, when obviously equipment's not running. So with that, you got to have a real business problem that you're trying to solve. The whole concept of starting small, but yet being intentional and choosing something that you can scale, you prove out the value. So by starting small, you can do the project, get everybody involved, and show the value and the benefit. Once you do that, the numbers speak for themselves. And so, once the numbers speak, then you get everybody excited about hey, let's continue to scale this at a rapid pace. So again, think big, start small, scale fast. That's really the model here.
Good. Isaac, I know you've had experience at a lot of different enterprises. Do you find that the company's attitudes towards return on investment varies widely from one to another, or is it pretty much all companies are looking for the same things?
I think automotive especially, I mean, the margins are thin, and continuous improvement is very, very important. So, I mean, me as an IT guy, I'd love to play with, AGVs and augmented reality and things like that. But they really, specifically in automotive manufacturing, they want to know what the business value is going to be in the end. And Detroit Manufacturing Systems tested out some augmented reality with their assembly process, and they quickly found out that the investment in that type of system wasn't going to return the ROI, and perhaps it made better sense to put that in their training center and just use it for training, which is what ended up happening. So I would say typically it is, they're not going to let you go down the road of a project, with playing with cool technology unless there's a good business case behind it.
Good. Mo, you work with a lot of different clients, and I think of IIoT projects consisting of three different types of technologies: sensors, the connectivity technology, and maybe the analytics side of it. What do your clients most struggle with when it comes to the challenges involved in launching and executing one of these projects?
Yeah, it's a great question, Kevin. And it's really a mix of technology, process, and people elements to it. And if you look at the automation pyramid, connectivity is usually an initial hurdle. So newer machines and older machines, they may require add-on sensors. Even if you have newer machines with newer PLCs, to really do predictive maintenance of some of the critical assets, add-on sensors like vibration is required. So to procure those vibration sensors and add them to the machine and acquire that data, there is an initial learning curve there. But once we go past that hump and we actually start analyzing the data, I would say another issue is actually validation. Because I can tell you this machine is going to fail in the next 2 weeks with a prediction accuracy of 90%. But how can you really validate that, right? Do you induce a failure? Do you wait for the machine to fail, which can take months, even years in some cases? So I would say in the beginning of a predictive analytics project, that connectivity layer, and kind of towards the end of that, how do you really validate that you're seeing the right results? That's a two-pronged question. Yeah.
And what makes the connectivity so challenging? Just that you have such a wide variety of equipment or systems?
I'll give you a short one and the team can chime in, but my take is sensors and hardware in general is getting very cheap. Computational speeds are getting very fast, but there's a multitude of machine types, variety, control types, and at the same time, a multitude of sensors and data acquisition hardware. So finding the right mix for your business and for your application requires domain knowledge, requires experience. So that's one side of it.
Good.
Yeah.
Tyrone, is there anything you'd like to add there?
Yeah, actually, I couldn't agree more than what Mo said. I think it's important to figure out that right recipe that makes in order to get the level of accuracy that you were looking for. But that is a learning curve. So that's certainly not and trying to make sure to educate the team in the organization on that is really important right up front. So that's probably what I would add.
Good. Isaac?
Yeah, I was going to say I had a specific example of we talk about different levels of plant maturity is a part of this, and we kind of started doing assessments of that because we had a project where a plant manager in Mexico wanted us to start doing traceability on their products, and at the end we came to him and said, you want to do traceability because you want to look at the data throughout the manufacturing process and then tie it to predictive quality, but you don't even have machines that are connected to the network. So in that sense, sometimes that can be a big investment if you're thinking the big picture of putting wires across the plant, putting switches in, plugging the machines in. The machines already had PLCs in them. They just never used it. They had no need to gather data until then. But I can tell you, with the start small concept, especially today with today's technology, you could throw a 4G sensor on there and start pushing that data to a cloud instance and start proving if it works or doesn't work. And then later you can go back and say, okay, it did work. Okay, how do we scale this? So yeah, that would be my take.
Good. And Isaac, to stay with you for another minute, what about the analytics side of it? I know you said in your presentation that you were starting to get into the analytics and the machine learning and artificial intelligence. What about the staffing issues there? What about the training that's involved? And what about your regular line people that have been there for a long time? Do they find this too much of a challenge to start thinking about things like analytics?
I would try to keep them out of it as much as possible. I do like to keep open communication to make sure they know what we're doing and that we're trying to help them. Because I think in general on a plant floor, anytime you start changing things, a lot of times with IT, they think they're spying on you. So it's the people process again, right? Make sure we communicate and tell them what we're doing. But I'm definitely of the concept of making sure that I have data scientists who know the data, and then matching that with the people on the plant floor who know the process, make sure they sit in the same room together and get those right people in the room together to share that information, because the data scientists aren't going to understand the process in your manufacturing floor, and the people who are on the manufacturing floor are going to not understand data science. So I think you have to have that mix, because it's interesting how the data scientists will say, hey, we're seeing this vibration level on this machine, and the people from the plant floor will know immediately what happened and why it happened, and they can share that information back to those people. And then it's definitely a mix, but I definitely wouldn't, it's like the old analogy of I'm not going to take a starting pitcher in baseball and put him in the outfield. I'll keep the data scientists and try to get those people in the room, and then take my people who I know are strong in the process of manufacturing, and putting those people in the same room together is really enlightening and interesting.
Well, Mo, what is your take on that? Is there any such thing as self-service analytics from your point of view? And does the take that different clients have towards the technology vary very much?
It's a good point. That's why, if I take the technology angle for a minute, that's why we took some domain knowledge that we've gained in manufacturing for things like robotics and presses running at Train, and injection molding running at DMS. And we created those solution templates, which have the analytics domain knowledge pre-built, but allows the data scientists to interact with the domain knowledge experts at the client and actually implement these analytics fairly quickly. And then to Tyrone's previous example about a center of excellence, you can actually have a team within the client with specific talents that are able to take those templates and actually scale them within the organization. So long story short, I think there is a cookie cutter approach to do it, and that's the template approach, but nevertheless, you still need the right process and people behind it to make sure it's successful.
Good, thank you, Mo. Tyrone, a question for you. Talk a little bit about the cultural side of these types of projects and how accepting people were of it, or what the stumbling blocks might have been, and how did you manage the change management side of it, if you will?
Yeah, great question. Certainly, as I mentioned earlier, that we started off very intentional with a heavy cross-functional engagement model. And the reason we did that is because of prior experience in other organizations, maybe where they didn't see that same approach. But I think we wanted to make sure that we started off with that level of engagement for a reason. And I think the culture aspect is, you cannot underestimate how important that is in this, because, kind of piggybacking on something Isaac said a few moments ago, you've got engineers, you got operators, you got technicians, and you got IT teams, you got people coming in that have I would consider SMEs or subject matter experts in their specific aspects of what they do. And so, and there's value in all of them. And so how do you, the culture perspective of how you get an engineer listens to a machine operator versus a technician listening to the IT team, and IT team listening to another function, and how they come together, that's the secret sauce. That's what makes this work, is if you can get in front of that, and so you can keep it simple, I like to say, for the, or stupid simple, like for the people to be able to understand how to make a decision, know normal versus abnormal, and they don't need to know all the details that IT can provide. They're gonna speak a different language, but they know how to react to a normal versus abnormal, because we teach that in our lean basics, right? And so to be able to determine how you react to that. So I think the culture piece of it, I can recommend, I can't state enough, you got to start off with that, being very intentional at the very beginning of some of these projects.
Well, thanks, Tyrone. Final question for today. It's a very simple one. We'll start with Isaac, please. And the question is, what's next? Please summarize the future you see for the Internet of Things and Industry 4.0 over the next 5 years.
Yikes. Technology changes fast. So I can tell you, a few years ago, they predicted the artificial intelligence. We're like 10 years ahead right now of where we thought we would be. And so the technology works, it's real. It's only going to get better. The sensors are going to get cheaper. It's going to be easier for us to implement the things that we're talking about today. Who knows? I mean, 5 years from now, as an IT guy, you talk about 5 years from now, there could be something that pops up that grabs a hold. But I think in general, as far as what we're talking about, it's only going to get easier and cheaper. And the companies that adopt this are going to get a step ahead of the other companies.
Well, thanks, Isaac. Mo, any thoughts?
A small thought, we talked a lot about connected assets, right? And predicting maintenance and quality issues. But maybe Tyrone can also speak to it, connected products. So we got analytics in the factory. How about analytics outside to offer my customers more customer satisfaction? And we also talk about connected worker. So how can I use analytics to support my frontline workers to do their job better in terms of error proofing, in terms of, Isaac mentioned augmented reality, but how can I really make it usable by the people, right? So I believe in a connected enterprise type of future, which is not just about machines, but it's about your digital thread from design to manufacturing to aftermarket. And there is a role of analytics and different ROI proposition at each stage. Yeah.
Tyrone, any thoughts, final thoughts?
I think Mo was reading my mind on that one already. He may saw the look on my face, what I was thinking. But yeah, in essence, I think that's what's going to change over the next 5 years is the whole, how do we, right now you see these type projects happening to focus or solve a specific problem versus across, hey, let's look at it from a customer value stream and how we think about from, customer to customer, the experience all the way through requirements, at the very beginning of new product development, and how you can actually interconnect that in a way that something happens, you can actually, drive reaction through the supply chain. You can actually automatically improve your, how you, think about your risk assessment processes for new product development. I think that the whole ecosystem when it comes to customer, that whole value stream, I think whoever gets there and figures that out first is really going to be able to separate themselves from their competitors. That's what I envision is going to happen. You're going to see more of that type of acceleration toward the customer value stream.
All right, thanks, Tyrone. We'll be keeping an eye out for that. That includes our presentations for this session. Thanks to Mo, Isaac, and Tyrone. And thanks again to our audience for joining us today. We look forward to seeing you in the chat session immediately following. Details can be found in the Additional Resources tab on the left-hand side of the screen. Now that we're just about done, in order to receive your continuing education PDH credit, you will need to pass the final exam in the final section of the session. Also, don't forget to take the exit survey after the exam. We use this information to improve our future events. On behalf of CFE Media, thanks for attending, and we'll see you next time.